Hi there, welcome back. Welcome to the second video in this restoration of this all-tube microphone mixer. I'm happy to report that the job is done and a few things were discovered along the way which I'd like to share with you. Basically, this mixer is divided into 4 sections. We looked at the power supply and that booster stage, or rather the driver stage in the first video. And basically what that is the power supply supplies each one of the tubes, the triodes. Effectively, these are double triode tubes, all of them. This is a 12A, what is it, a Y or a T? AU. This is a 12AU7 up there. And these are 12AX7s, all of them. Now what do we have here? Well, basically, all the power supply lines had to be brought down here, and I'm happy to say that they actually came out quite well. The heater wires were rewired, thicker wires, as I mentioned. These things draw quite a bit of current, and the wires they had in here were just not adequate. These tubes, these 12AX7s, draw in parallel as they're wired at 6.3 volts. They draw 300 milliamps each, which means 1.2 amps down here. That's quite a bit of current. And then there's another 300 milliamps up there, and there's another 600 milliamps for the tube rectifier. So it's quite a bit of current, and certainly those little wires, those sort of Cat5 wires they had in here, weren't doing the job. But what we have here is that top section. I call that the driver section. That's a double triode. Then down here, what do we have? We have each of these is a microphone preamp. Okay, so basically this section here is identical to that one, is identical to that one. And if we look at it, the way that I did this was to dismantle this whole thing. I had to take everything out, clean it, rewire some of the connections. Some of these caps were reused, so I had to sort of rewire some of them, make them a lot neater. There was a serious risk of shorts in here, the way it was wired. Those old resistors were all out of spec. I think without exception, they were all out of spec. And the capacitors, again, without exception, I think were all in spec. So those all went back and the resistors were all replaced. Wiring was rerouted slightly, and I had to be very, very careful here. I didn't want to change the entire character of this thing, but I had to make sure that we didn't have any risk of damage or shorts or unnecessary hum caused by the wiring. So I tried to do this, as good a job as I could. But anyway, this is one section, and the result of this double triode, so we've got the input transformer there which feeds one of the triodes, which boosts the signal. The signal then comes to the second triode, and it then comes out of the pot, if I'm not mistaken. Comes out here through that sprog. It's the result of the 2 triodes doing amplification on that signal, and it comes out here. Now that transformer is basically to allow a 50 ohm input. It's the best way to couple your microphones into a preamp, so that's a good thing. The result then comes out of here, which is the anode of the second triode, and it goes to the top of the pot. Now, if you take this and you imagine all of them in the same configuration, so that one is the same thing, you've got the signal coming out here. That one's the same thing, signal coming out here. Now your fader, this is what these were called. They were called faders, A, B, and C. As you turn up the fader, the proportion of that signal starts increasing at the wiper of each of these. And these then go through another resistor, each of them, and they get summed. They basically feed that section. Now that section is, again, a booster section. It's the summer and booster section for this stage here. And boost is the operative word here. This thing's got an enormous amount of gain, but we'll come to that in a second. So this thing has another dual triode in here, and one triode does raises the signal a little bit, and the other one, and then it goes through the pot, so it goes through the wiper, and the other one again acts as a sort of buffer amplifier as well. So we've got quite a few amplification stages, and then this from here goes to the top there, which is to the input of that tube that we saw in the last video, and this is the summed signal, which then gets amplified and pushed through that output transformer at the top there. That output transformer is a 10,000K to 600 ohm. So that output transformer is providing a 600 ohm output, but a 10,000 ohm load to that triode over there. Okay, I'm going to show you in the schematic what all these sections, how all these sections are. I traced the entire schematic, and in doing so you learn an enormous amount of stuff, and it gets really interesting. The first thing I noticed is that this thing was obviously built by a techie. It was built probably by the engineer who needed a mixer. I don't believe this was a commercial product. And the reason is that there were actually sort of a few mistakes on here. Not that it didn't work, it obviously did. I mean, this thing was used. And I'm loath to, say bad things about a product that probably A, is older than me, and B, probably worked a lot more in its life than I have. So yeah, somebody built this to their own spec, and they might have had very good reasons for it, or they might simply have not sort of thought about it too much. But the way this is built in two tiers creates a problem. And the problem has to do with noise and hum. It's got to do with the way the power supply is linked from the top to the bottom here. The fact that you've got an audio signal at the top there and all the sensitive signals at the bottom here. The filtering they have on there would probably have been a lot easier done if it was done here. For example, all these are B pluses. If you remember the first schematic, I had B1, B2, B3, B4, B5. Well, this works like this. B1 and B2 up there, B3, 4, no, B1 up there, B2, 3, 4, and 5. So this B plus here, this red one, is the one that's straight after the supply to the top one. So it's the one that is going to feed a tube that's dealing with a slightly higher level signal, so it doesn't have to be as filtered, and then each of these are filtered identically, but these are supply lines. So if you think about it, one of the ways to do that would have been to put that filter capacitor up here. This is where it comes in. If you put that filter capacitor there to ground, and you create a star ground, which this thing does not have, you'd probably have created a cleaner supply and probably a less noisy result. And I don't know how noisy it is. I can't test this, and you'll understand why in a second. But let's have a look at the schematic and look at these individual sections. So sort of microphone preamp and fader, the mixer and the summer circuit and booster, and then of course the top end we've got the output transformer driver and headphone amplifier. Here we have the schematic, the complete schematic for the equipment, and I'm going to start here, and we'll go through across and follow the schematic as we develop it. So here we have the input. That's the XLR input for the microphone. Signal comes in here. Here obviously it's a balanced signal, as you can see. Here it becomes single-ended. That's a secondary transformer which feeds directly into the grid of this one tube. This is one tube. This is the one section and the other section. Forget about these numbers. This is one tube, okay? And what we have here is a simple voltage amplifier. It's cathode biased with a 3.3K to ground and a 250K to B plus. In this case, it's B3 plus. Now, what I can tell you here is this is very high gain, which is fine. You need a lot of gain in the beginning so you can overcome sort of the noise floor, the noise threshold, whatever you want to call it. So that signal is then fed or coupled through that capacitor, 100 nanofarads, to a 650 grid leak resistor. So this is then fed directly into that one, and that's another voltage amplifier, biased slightly differently, less gain because of the size of that resistor, and the resulting signal comes out of here. This is that Sprague capacitor that you see there, and it comes out here and it goes to the fader. So the full amplified signal from there, full gain to there, is then selected with setting the level of your fader, and you go through a summing resistor, this 270K, and you get your first signal joining that network over there. Now, The other three are identical. That's why I've got C and B and A here. Okay, so the B and C are identical to this. What can I say about this? Well, there's it's sort of convention that it's a good idea to have grid stopper resistors. So you would have a resistor here, probably about 1K, that would stop some oscillation. It's not necessarily obligatory, but it's a good idea. Not so sure you'd need it there. This thing has got a lot of gain, And if I look at some of my notes here, what I did was I fed a signal. I took this signal here, this here, and I connected that to ground. So I made it single-ended because I wasn't able to isolate my signal generator from the scope. So I made it single-ended, and I fed a signal in here, and I measured the voltage level here. So what I got was, well, with a 10 millivolt signal on here, 10 millivolts RMS, over here I got nearly 16 volts. Now that is that in itself is 63 dB. That's pretty good gain, right? 63 dB, perfectly clean wave, no problem, okay? So I'm going to test the gain of the first stage, and I've got a 10 millivolts RMS signal coming out of the signal generator. I've got that going into the transformer, the input transformer, so effectively where the microphone will be connected. The yellow lead clips the negative or the cold side of that input transformer to ground, so I'm making it single-ended. Then I'm taking the signal out here, monitoring it here with the scope. That's the Sprague cap that connects or clips to the, or couples to the top of the of that pot. I've got the pot down on 0, okay? So I've got nothing going through, but it's getting to here, obviously. And what my scope is reading is 15.8 volts. Okay, so 10 millivolts in is 15.8 volts out. And that's exactly what I'd measured before. And unless I'm wrong, my calculations give me 63 dB of gain on there. As you can see, pretty clean. I've got a 10 millivolt signal, which would probably be higher than most microphones. I'm not even quite sure what the microphone levels would be, but that's what we get coming out of there. Now, I have to be careful how I measure the rest. Then you take these three and you sum them through this resistor network, okay? And this resistor here gives it a ground reference, but it also acts as a voltage divider. So your signal there, if you put this at the top and you've got 16 volts on there, you probably have about 7 volts here, okay? Because it creates a resistor divider between that resistor and that resistor. However, what I did then is I fed a signal into here, but I'll show you that as we go along. All right, the signal comes in here, and what they've done here is they've created an LC circuit, an inductor and a capacitor circuit here. This was obviously to prevent, or I believe it's obviously to prevent oscillations. And I don't recall seeing, and I can't remember what the value of this inductance was, but it was pretty big. And I don't recall ever seeing an inductor, the input to a voltage amplifier. Not like this. The other thing is this capacitor, 500 picofarads, is pretty big. So relative to the cathode to, or grid to cathode capacitance on the tube. So what this does is basically, this is the Miller capacitor. This is increasing the high frequency cutoff of that signal. It creates a high frequency, basically a low pass filter. Now you could work out where the turning frequency is, where the 3 dB point is, but it does cut off high frequencies. So it obviously acted as some sort of high frequency oscillation preventer, okay? Then what you've got here is another voltage amplifier, triode voltage amplifier with quite a lot of gain again. Another 270K up here, 3.3K over here. So a lot of gain on here. And what they've done is they've put a cathode bypass capacitor of 47 nanofarads, which what it does is basically it's probably compensating somewhat for the high gain or the high frequency loss that you have on this, the Miller effect of this capacitor. So you're cutting high frequencies off here, but what you're doing is by choosing a 47 nanofarad, you're sort of raising the high frequency gain here as well. So in effect, you're sort of balancing this out, I guess. I guess that's the idea. My guess is somebody tested and saw what kind of value would work and just put that one in there. But hey, that's my guess. Signal comes out over here, amplified quite a lot, especially since you've got a cathode bypass cap. And it comes to here to the master volume control, the master level control. Again, what you do is you adjust your level before you feed it back into the second triode of the same tube. As I said before, these numberings are wrong, okay? These were because I copied from the schematic to get triodes. But this is the same tube. This is two halves of the same tube. And it comes in here, and again, you've got that millicapacitor there to ground. The ground reference is done through the pot, so that's not a problem. You do have a ground reference for that grid, but you do have a cutoff here. And again, it's biased with a slightly lower gain than that one. And again, you've got something here which is a little bit strange, and I'll explain. The output of this comes out here, and it goes into that top tube, the one that I mentioned was driving the transformer, the output, and driving the headphone. And you've got a feedback resistor from the output here. It's the same output that drives the transformer. From there, you've got a feedback network, a capacitor to DC couple, to AC couple, and a resistor which reduces or increases the amount of feedback. But then you've got this thing. You've got, again, a 4.7 N resistor to ground. So you basically, for certain frequencies, this feedback doesn't work at all. It just gets shorted to ground. You would normally not take a feedback loop to a cathode, which is a good place to put it in, perfect place to put it in. It's negative feedback, so it would affect the gain of this whole loop here. In fact, the entire loop. But you wouldn't short it to ground for certain frequencies unless you wanted to frequency taper it. So this feedback is not working for certain high frequencies. It's only operating for certain low frequencies. Again, that might have been intentional. I have no idea. The result is the output comes out here, and it goes and it feeds into that one there, which we've seen before, which drives the transformer, and it goes off that way. I've connected the probe to the output of that summer circuit, or that mixer. That's the output there. That's the one that's going to go to the driver. And what I've done is I've put the volume pot, the master volume, on max, and then I have attenuated over here. I've started increasing this pot very slightly till I get a certain voltage at that output there, and we'll see what we're getting at the output, and then we'll come down here and see what it is we're feeding into that stage. So what we've got here is 16.8 volts. 16.8 volts is the output of that mixer buffer thing. Okay, now I'm going to change the scope to the output, to the wiper of that fader, and see what it is we're feeding in. So we are feeding in 320 millivolts. So 320 millivolts is translating to 16.8 volts at the output, and that is about 34 dB. That's the gain of that buffer, summer buffer stage. Okay? What we also have here, this section here, which I hadn't done in the last video, is at the output of the transformer, which is a 600 ohm output. This transformer is 10K to 600 ohm. Okay, so it's about a 12 dB, if you work it out, 12 dB drop. The output drives that meter, and it has a pad over here. Now, this is the problem. This pad is supposed to be, I think, a 4 dB pad. It's an H pad. It's a balanced pad, attenuated pad. And I believe the idea was that it was 4 dB drop, because if you go to a H-pad calculator and you put 4 dB, you'll find that these resistors are 120 ohm, but that one is certainly not 1.2K. In your calculator, I think that one comes out at about 500 and something ohms. So somebody sort of, well, I think they just sort of got it wrong. To measure the gain at the final stage of that buffer stage, what I need to do is I'm going to take the scope from here, and I'm actually going to connect it to the anode circuit, or the anode output of the driver tube. So I'm going to connect it to this output, which you can't see up here, but it's the output that's driving the transformer. And I get a huge signal. Anyway, I'm getting a signal which I'll show you in a second. That's at the output, and then I'm going to see what it is that I'm feeding into here. Okay, so I'm going to then move the probe down to the bottom. There it is, the moment measuring the output of that, or the anode of that driver triode. And what I'm getting here is 89.2 volts. And that 89.2 volts, when it's translated to the 600 ohm secondary, will be 4 times less. So we'll have to take that into consideration, but we can actually do that, and we'll do the sums, but I want to show you what it is we've got at the input. Now, if I take the scope probe from there, and I'm going to move it to where we had it before. Now, I adjusted this so that I didn't overdrive that. But what do we have there? That's our input to that stage. And that is 16.7 volts, so it's still there. That's what we've got. This thing has an inordinate amount of gain. As I said, from my calculations, and what I've done is I haven't connected this to an output. I have a problem. I don't have a balanced input amplifier, and you've got to be careful if you single end this over here, because you've got the pad in the way, blah, blah, blah. It gets a bit messy. So if you use this thing in single-ended, if you use signal 2 and 3, the balanced, the hot and cold signal as your input to an amplifier, you cannot have your signal generator grounded. And of course, my amplifier and the scope that I'm looking at, everything is grounded to earth. So I've got to be very careful how I test this. Now, this section here, if you measure at the output over there at the anode, gives us another 15 dB. Okay, so we're talking about 112 dBs up to here. Then this transformer takes your 10K signal down to 600 ohms, and if you work out the ratio, 10,000 divided by 600 comes to about 16. So the voltage gain or drop is square root of that, so it's about 4. So whatever's here is 4 times less there. It works at about 12 dB, so you subtract 12 dB. Okay, so you're at 100 dB over here, and then they've got this, what's supposed to be a 4 dB pad, so you should get 96 dB. So that's basically it, about 95, 96 dB. And in fact, I believe that's what I got. I put my signal generator, I put it through a attenuator, stepped attenuator, to get 0.5 millivolts over here. And the result at the end was 20 something volts over there. So this thing has got a huge amount of gain, obviously with the wipers on full. And that's what worries me. You cough and this thing goes, and the needle on the front there just shoots up. You just make some noise on the microphone and the needle goes crazy. That's a schematic. There may be some errors. There's obviously labeling errors on the tube numbers, but I know that. I'm a little bit like the guy who built this thing. I know where the mistakes are. I know how to sort of coax this thing to work, and I know what it's like to build your own equipment, and you're the only guy who knows how to use it. I understand that fully. I've got a lot of test gear here that I'm the only guy who knows how to use it, because I built it for myself, didn't label it, didn't think of a market, didn't think of creating an instruction manual, because I didn't intend anybody else to look at it. And this is more or less the result we get. From here to here, we get 10 millivolts amplified to 15.8. That comes to 64 dB. Then from there to there, we get 320 millivolts amplified to 16.8, which is another 34 dB. Then from there to there, we get 16.78 amplified to 89.2, which is another 15 dB. Then that works out to minus 12 dB. And then you've got the H-pad, which is supposed to be minus 4 dB, which means we've got 64, 68, 98, 113, 101. Well, that's 97 dB is what my calculations give me. This thing has a gain of about 97 dB if you put the whole thing flat out. Now, the problem is, I tried this with the microphone, and I tried connecting this to the workshop amplifier, and the result is scary. I can't get a low enough signal on here. These faders, and also I don't have a balanced input, so I need to, I guess we need to find another way of actually doing the final test. But this is the result. This is the result of that restoration, and I've got to tell you, interesting job. But there are quite a few things that I would do differently. So let's have another look at that. You know, one of my subscribers mentioned or commented that he finds it quite amusing that people in Europe are surprised to see these things that somebody built and used. And in his case, in the States, he says that it's quite common, especially at the swap meets and everything else, to find a lot of equipment that people built themselves and used them in actual professional operation for years, and they're now selling it. And we're not so used to that in Europe. I'm pretty loath to actually criticize this because I'm aware that this thing was used. This thing was built, used professionally in a radio station, probably was part of endless number of parades through the town that it was in, you know, country fairs, I don't know what kind of shows and public events that they had there that the radio station might have wanted to transmit live from. So this thing's been in operation, and it did a good job. And at the time, hey, that's what they needed. They needed something to mix microphones in the field, as it were. And this thing was good enough for it. Remember, they were transmitting on AM, so you know, the quality of the audio was not so critical in those days. They probably had very low-level microphones, so lots of gain was probably desirable. The guy who built this was probably the operator, so he knew that, you know, that pot there, you've got to be careful how you twist it past 3 o'clock or something. He knew all the tricks of this thing. If you had to rebuild this from scratch, I would do it differently. First of all, I would not create a double-decker thing here because it does create problems with the supply. Especially, it creates problems with the ground, because in some cases here they've used the chassis as the ground, and of course by the time it gets to the ground, which is the real ground, which is the capacitor grounds at the top there, you've gone through quite a lot of real estate here. So perhaps that's not the best way to go about it. The heater wires, I would have done it differently. I would have given it a bit more space. Perhaps if he'd built this flat, it might have worked better, but he did a good job. He made it work and he used it. So I'm going to finish off here. This job is done. I'm just going to put it back into the case, and I'll be very interested to know how my friend gets along with it when he gets his full tube recording studio set up, which is what his goal is. And this is a small part of it, a very small part of it. But I'm very interested to see how it comes along. And this, my friends, is where we sign off. I'm a bit careful with this thing because it is sensitive. And it is older than me, so I would like someone to treat me respectfully in the future, same as I do this one. Let me put it back in the case. And that's it, my friends. We've come to the end of this project. Here's a view of the remains. They're all resistors, and here she is. You don't see much difference. The idea was not to make it look pretty. It was to restore it internally, electronics, and I think that's been done. Now all that remains is for this thing to be properly tested by my friend who's got the setup to do so, and probably a lot more experience with recording than I have. Not probably, definitely. So I'm just going to sit back, give it back to him, sit back and wait for him to tell me what it sounds like. I'm keen to see the results. Hope you've enjoyed this, and I'll see you back soon for another video. If you've enjoyed it, click like, share, subscribe, and all that jazz. And stay well, stay safe. Bye for now.